Good afternoon, all. I welcome you all, those who are in person and those who are online. And now I request Professor P.D. Nayak, Dean HBNI, to give the welcome address.
Hello. Good afternoon and wish you all happy Teachers' Day. And I thank you for joining HBNI Teachers' Day program. I'm P.D. Nayak on behalf of Homi Bhabha National Institute and my behalf. Welcome you all for this program. In fact, many of the dignitaries have joined online, either on WebEx or YouTube platform. I welcome them all for the function. I welcome our chief guest today, Professor Devang Khakhar, Professor, Department of Chemical Engineering, IIT Bombay, and former Director, IIT Bombay. BRC and faculty from BRC, Professor Nayak, Associate Dean, HBNI. Thank you all for joining us. As you know, 5th September, Teachers' Day is very important day for all of us. We were and are beneficiaries of the knowledge and skills imparted to us by our teachers and other associates. Teachers, right from primary school, molded us to think rationally, and credit for our all achievements goes to them. In fact, it is impossible to describe the contributions of the teachers in our life. But I will recite the Sanskrit shloka, which describes aptly these teachers' contributions in our life and value in our achievements. Guru Brahma, Guru Vishnu, Guru Devo Maheshwara, Guru Sakshat Parabrahma, Tasmai Shri Guruve Namah. These only the things you can think about any God, Goddess and other things is far beyond any of them, and is like a Parabrahma to all of us, given everything, and because of their contributions, we are here in our life and living whatever and achieving some of the things, and all this finally goes to our teachers who molded us. So once again, I salute all the teachers who taught me during my primary school. In fact, I remember my primary school teachers. It was in village and we have only 7 to 8 students. I used to do very good. But I never got more than 80% in my school days. When I gone to high school, my teacher called me and told us, I given you not more than 40%. because I don't want that you should be getting really proudish and not to concentrate on your studies. Because in high school, I used to get more than 90% all the times. She might have came to know, and then she called me and informed. And that's what they molded us. Be humble, and whatever we are today, only because of them. And primary school teachers are very important in our life because that was our tender age, and they shown us the right path, how to behave with other seniors, peers, and other things. I think whatever we have today, and the credit for whatever good in us goes to them, and bad we have achieved because of many other things. With this, I thank you all for joining us, and welcome to this function. Thank you.
Share that presentation. Thank you, Rishabh. This nice presentation is made by one of our research associates, Dr. Oiseria. Now I request our Vice Chancellor, Professor P.R. Vasudev Rao, to give introductory remarks.
Professor Devang Khakhar, the chief guest for today's program, Professor Grover, Professor Joshi, my colleagues at HBNI and faculty from BRC who have joined this program here, and other members who are online, and also invitees, some of the names I can see on the screen. Thank you very much for joining, and I joined Professor Nayak in felicitating all the teachers here on the occasion of their Teachers' Day. And we are particularly delighted that we have three gurus here, Professor Khakhar, Professor Joshi, and Professor Grover, who have molded a large number of students. All of us are fully aware of the influence that teachers can have on our career and also our lives. In fact, whether we like a particular subject or not, or whether we want to choose a particular career, can be easily influenced, greatly influenced by teacher whom we adore. The teacher's role goes beyond teaching in the classroom. In fact, it's extremely crucial in allowing and promoting free thinking and the spirit of exploration among the students. I only want to quote a few statements made by very, very eminent scientists which illustrates these. Because to start with, Albert Einstein said on teaching that I never teach my pupils, I only provide them conditions in which they can learn. So it's not important to put in a lot of facts and ensure that the students memorize those facts. The philosophy and the process behind any research should be understood by a student and not necessarily the data alone. We can appreciate the fact that a teacher's role is very important for students who are slow in learning. That's very easy to understand, but it's equally important for the brilliant students. And for this, we have the example of Richard Feynman, who in his letter to his teacher, Mr. Bader, he mentioned how he was molded by Mr. Bader. He says, and I quote, Mr. Bader, you certainly knew how to stretch a young boy's mind to the utmost of achievement and knew how to handle an exceptional student. Handling exceptional students can also be as difficult as handling slow learners. Usually the truly outstanding student is left to go in his own way. Okay, you are great. You just read and write the exams. Don't bother about attending classes, whatever. But when Bader found Feynman in his class, he specifically gave him great challenges. He gave him good advice, but also fascinating information about physics, which triggered him. He excused him from paying attention in the class, but challenged him to learn advanced calculus. By giving him a book from his personal library, he said that you don't attend my lecture, it's fine, because I think that you already know many things, but I want you to read this. So he gave him a book from his home and made him read. The students' love and admiration for his teacher resulted in the boys wanting to become a teacher and a scientist later, and we know what kind of contribution he made. The books titled Feynman's Lectures on Physics are just like Bible for any physics student. The other example, Stephen Hawking himself. He was inspired by his teacher at the young age of 14. He told him, do maths, do more maths, and much more maths. He remembered it later on because his own student, who went on to become director of the Institute for Quantum Computing, Raymond Laflamme, he said in his remarks, I learned a lot from Hawking about the universe, but I believe I learned much more about the spirit of exploration. He taught me as much about courage and humility as he did about black holes and quantum mechanics. It's a debt that I fear I will never be able to repay. Coming to examples in nuclear science, we know Ernest Rutherford, who won the Nobel Prize for his work on radioactivity. He acknowledged very publicly in his lectures that his teacher, Professor Beckerton's genuine enthusiasm for science only gave him the stimulus to start exploring a very, very unusual territory at that point of time. Nobody could think of what is happening in the radioactivity, why emissions are coming from the nucleus. If he had indulged in experimentation, it was because of the encouragement he got from his teacher. Similarly, Glenn Seaborg, who discovered plutonium, he has very clearly acknowledged that he became a chemist only because his chemistry teacher was a very interesting teacher and he liked the subject by listening to him. We are very, very fortunate that today we are joined by one such teacher, Professor Devang Khakhar, former director of IIT Bombay and a professor in the Department of Chemical Engineering, who has made a great difference to a large number of young aspirants through his teaching and guidance and his leadership of IIT Bombay, which saw a great thrust on innovation and young entrepreneurship and so on. We are also very glad that Professor Grover will be speaking on this occasion. It was his efforts which led to the establishment of the HBNI itself. And we are also thankful to Professor J.B. Joshi And the fact that many of the students of Professor Khakhar have joined online shows the respect they have for him, and in turn it shows the contributions he has made to the field of education. In the context of HBNI, I have to say this: the mandate of HBNI is unique in that it focuses on human resource development for the energy needs of the country and the health and well-being of the society. If I can put two major objectives, these are the two major objectives. And therefore, faculty in HBNI have a great opportunity to mold the research career of the students by not only teaching them the concepts or the processes, but also inspiring them to take up the challenging assignments that await when they work with DI, or those which are highly relevant to societal needs like development of technologies for agriculture, security, or water, or whatever. I can visualize that with the thrust on green energy for the country, the role of nuclear energy is going to become more and more important. And if nuclear energy has to grow, availability of high quality human resources is going to be an important factor. And thus, I am sure that our faculty can play a very key role in national development through teaching and education. Finally, I want to say that in the domain of research, teachers also continue to remain students. I don't think we can claim that we have learned everything that we can. Learning is never complete. It's also therefore important that faculty constantly update and upgrade themselves to be in a position to offer the best to the students. It is with this view that we are organizing webinars on frontline topics regularly, and we have also started organizing team meetings in individual disciplines where faculty in a particular discipline can gather together and learn about work being done by the others and advancements in domains which are related to their work. A team meeting of faculty in life sciences, in fact, is being organized from day after tomorrow, September 7th at RR-CAT Indoor. Earlier, we organized one on physical sciences. This trend will continue to make faculty from different institutions under HBNI meet together and discuss the advances in that relative area so that each is able to learn from the other. This learning process should be continuous so that we are able to say that we are current with respect to what we teach. I hope that more and more of the faculty members will attend participate in such meetings and get benefited. And on that note, I would like to conclude my remarks, and I thank all of you for joining. And I once again thank Professor Khakhar for sparing his time to be with us on this special day. Thank you.
Thank you, sir. Now I request Professor R.B. Grover, Founding Director, HBNI, and Professor Emeritus of HBNI to give his address.
Professor Khakhar, Professor Joshi, Professor Vasudhara, and dear colleagues. I think we are here to listen to Professor Khakhar, so I'm going to be very brief. First of all, I think the brief PowerPoint presentation on Dr. Radhakrishnan was definitely very timely. I thank the person, a research scholar who has made it. I like to add one point to the information which was embedded in that PowerPoint, that Dr. Radhakrishnan was the chairman of the first education commission set up by Government of India immediately after independence. I think it was just early 1948 that commission was set up. And if we look at the various commissions and committees set up at various times by the government, three stand out. One is the Dr. Radhakrishnan's commission. Second, the commission which worked under the chairmanship of Professor D.S. Kothari in mid-60s. And the third latest now, NEP 2020, Dr. Kasturi Rangan. So sometime back, a few years back, read the report of Radhakrishnan's commission in connection with management of HBNI to understand how one has to proceed further. I was struck by one particular feature in that report. He uses the word samanvay, and this word, Hindi word, is written in Roman alphabet right in that report, quoting from Upanishad. So one just tries to see that we are talking about multidisciplinary approach, integrated education that is embedded right in that report written way back 1948, 1949 period. And we are coming back to those concepts. Second point, which is noteworthy about that report, he himself was a philosopher, student of philosophy throughout, but he's talking about utilitarian values of science and technology, the way we have to use research to advance our economy. Now, just see a person can balance both the things, and that is what also comes out from that report very, very clearly. I think coming to my own association with the profession of teaching, well, I must say that somehow because of the atmosphere which we had in our home while growing up, love for academics was embedded into our value system right from that time. My father was a principal of a higher secondary school. We used to always grew up looking at towards him, and that is how love for academics was embedded in our value system. And when I graduated from Delhi College of Engineering, taking up a profession was never my idea. My thinking was to take up MTech, PhD, and move in that direction. But it came to for interview here under family pressure, because that was a time when engineers were unemployed in very large numbers. And here I was selected. That was one of the early interviews just a few weeks after graduation. And I spoke with people of the senior batch whom I met in the mod lab where interviews were held. And they explain about training school. They explain what kind of academic atmosphere is there here. And that's when I changed my mind. I do not know who those students were, 13th batch students who sort of oriented me in that direction, unknown persons. And finally, I ended up in training school. And then rest is, of course, left all my career here. Interesting thing happened just 3 years. I was in 14th batch. I started teaching from 17th batch onwards. And the subject which I was teaching was heat transfer and fluid flow. And I used to feel very elated about it because till 1969, Professor Sukhatme was teaching that subject. I was thinking, okay, I'm stepping into the shoes of that person. That gave me a feeling of real elation at that time. Of course, then I became a member of the selection committee in 1975, then chairman of the selection committee, teaching in training school and being associated with selection. That continued like this till 1990. Full-fledged association with the training school somehow continued it. Then there was a brief period of 10 years where officially I didn't have anything to do with training school. Then I became associate director of a group, and training school was a part of that. And that has continued till my retirement. It has been a nice experience dealing with teaching, dealing with research, dealing with selection of the students. And in between, we started a scheme, okay, how to collaborate, how to take benefit from the education system in the country. In 1999, we started a pilot scheme with IIT Kanpur, where we said, okay, we'll faculty from IIT Kanpur and BARC will jointly select students who will complete MTech in nuclear engineering at IIT Kanpur and subsequently join BARC. So that sitting jointly with the faculty from IIT Kanpur and us was another experience which gave me a different insight. After the end of interview in the first year, Professor Kalada, Professor Munshi, who was dealing with nuclear engineering department there, and myself and along with me was GP Srivastava. So we were discussing and trying to analyze what has been the basis of selection. One thing which came out was that this came from Professor Kalada there, MS Kalada. I do not know whether you know him or not. MS Kalra. He was in nuclear engineering department there. So what it came out after analysis was that when faculty there was trying to select a person, think of a person, they were looking at, okay, will this person be able to complete MTech? Will this person will be able to write a thesis? And when those of us who had gone from Mumbai were looking at person, we were looking at, okay, will this person, how will it last for the next 40 years in DAE? Total thinking was different. And then something dawned on me that way we conduct our training school, it's not that whether a person will graduate from training school, we look at how will, this is somehow built into our system, not that somebody had told me. So I was associated with the interview process, with the teaching process for a long time. It was when at IIT Kanpur, when we interacted with them, then it really, I realized that this is really the difference in the process of selection. In university or IIT or anywhere, the student is there for a given period, and the faculty has to judge whether that person will be able to complete that particular course. But our thinking is totally different. Then another thing which I realized over the years, in a university, for every subject, they may have a VIOC. It is confined to that subject. In our training school, we are end semester VIOC. We are all the subjects which have been taught in that semester are a student is examined for all those subjects. We are looking at, again, an integrated way, the knowledge of subjects, not individual subject-wise. This is a very, very important feature of our training school. And this, I don't think anybody thought theoretically on these things. This whole thing has evolved over the years, because when I joined, end semester Viva was there, from which batch it started, how it started, that history I have not been able to find out. But these are some of the features which we have in the training school. Well, here I think there's one topic which I have been speaking again and again, always whenever we talk about Homi Bhabha National Institute, why it was set up. The basic reason approach, as I see it, if academic research and post-academic research, they are carried out together at one place or in close proximity, you always get faster results. You are able to transition from research to deployment much faster. And that is what has been our attempt in HBNI. Now, I think in whichever disciplines, there is engagement of universities with the stakeholders, results are very good. The best sort of discipline where this has happened in our country is agriculture. Agricultural universities with their extension centers, they are really engaged universities. And result is, we know that to what extent agricultural production in the country has increased after independence till now. Other areas where we see similar engagement in chemical sciences, the way chemicals, fertilizers, petrochemicals, those industries have grown in India is much superior to many other areas. I find similar thing happening in biosciences. We have seen in the pandemic how virus production of vaccine could be speeded up, and how we have been able to become the vaccine factory of at the global level. So when NEP talks about engaged universities, we already have certain disciplines where it is happening, and this has to extend to all disciplines so that the country really can benefit from the fruits of education and research that is going on in academic institution. I'll stop here so that we can listen to Professor Khakhar.
Thank you, sir. Thank you, sir, for a wonderful talk again. Okay, it's my honor to introduce our today's chief guest, Professor Devang Khakhar. He did his BTech in Chemical Engineering from IIT Delhi in 1981 and PhD from the University of Massachusetts Amherst in 1986. He joined the Department of Chemical Engineering at IIT Bombay as a faculty in January 1987 and has been with the institute since. Just switch on, yeah. Professor Khakhar has served as professor in charge of IIT Bombay's continuing education program, head of the Department of Chemical Engineering, and Dean of Faculty Affairs. He was the director of IIT Bombay for 10 years during 2009 to 19. Professor Khakkar's research interests include mechanics of granular materials and polymer processing. He has published over 100 papers in these areas. He has guided more than 30 PhD students. Professor Khakhar has been accorded several prestigious awards, which include Santi Swarup Bhatnagar Prize 1997, then Swarna Jayanti Fellowship 1998. He is also a recipient of IIT Bombay's Excellence and Teaching Award, Mathur Award for Research Excellence. He is a fellow of the Indian National Academy of Engineering, Indian National Science Academy, Indian Academy of Sciences, National Academy of Sciences, India. He serves on the Science Advisory Council to the Prime Minister of India. It's closed? Okay. He was serving. Okay. Scientific Advisory Committee of the Cabinet and Central Advisory Board of Education and Atomic Energy Regulatory Board. He also served as the executive editor of the journal Advanced Powder Technology. He is an independent director on the board of Indian Oil Corporation and Antrix Corporation. With this, I request Professor Thanger to give his talk.
I think this is good because it has to come on all the screens. So thank you, Professor Maiti, for the kind introduction. Yeah, there is, I don't think there is a Science Advisory Council to PM right now, but many of these were in the past. But I'm very happy that I'm still serving on the Atomic Energy Regulatory Board. And that is a really very enriching experience for me. Professor Vasudeva Rao, Professor Maiti, Mr. Nayak, Dr. Grover, Professor Joshi, good afternoon to everyone, those who are here and those who are online. It's really an honor for me to be here on this auspicious day where we are celebrating Teachers' Day at HBNI. I thought, today I'll talk mainly about my own experience. This year I completed 35 years as a faculty member in IIT Bombay. And I thought I'll just give some reflections of my experiences in this institute. Yeah, is that? Yeah. So let me begin by wishing everyone a very happy Teachers' Day. Of course, the training school and BRC has had a long academic tradition. Everyone, besides being researchers, have been teachers and have really been committed teachers. And then with the formation of HBNI, I think that all of you have taken on this additional task, a very important additional task of teaching. And, all these numbers behind are the sort of impressive result of your efforts. So happy Teachers' Day and congratulations on all the achievements that HBNI has been making over the years. I thought I'll give this, say a few things about the importance of good teaching. What are some of the elements of good teaching? How can we learn to be a good teacher? And then, so those are very general remarks and brief. And then I'll review a couple of reports that I have been reading on the future of education and what the role of technology will be. And finally, I'm going to talk a little bit about teaching and research and the role of computations. So of course, many of the subjects that I'm talking about are actually areas in which people are doing serious research. That is how to teach better, how to do better research and so forth. So this is not that kind of talk. This is more based on my own personal experiences. So let me begin a little bit with teaching and research and the importance of teaching. And I think both the previous speakers have emphasized this. But, since you are all teachers at HBNI, I think the main product of HBNI is the education that you provide. And that goes with the graduates, those who graduate from the institute. A very important part of this education is the courses, because, they literally shape the way that the graduates think. They enhance capabilities because, you imbibe all the new knowledge and concepts and so forth. And as was mentioned, this is not an impact that happens over a short time, but the benefit is over the 40 years that they will be working in various professions. So the impact is very large. But beyond that, as was already mentioned, that teachers have a great influence on graduates by giving them a broader understanding of the field. Like you were mentioning that, the connections through the vivas and so forth, but also through their own enthusiasm, they convey a love for the subject. And, students may also imbibe that. An ability to think and be creative, as well as an urge to excel. So, these things just happen as part of that process of delivering the material. Though HBNI is not engaged too much in this, but I feel that this is one point I felt for a long time, that undergraduate education is particularly important because the foundations are set over there. And in many of the best of universities, it is the top professors who are teaching the first year and second year students because they essentially provide that foundation which is so important for them to go and rise to much greater heights. And I think this is something that is missing in many of the universities, and I hope that in future there will be more emphasis on undergraduate education, because in a sense, if you actually look at the overall contribution of all graduates, the undergraduates are the most numerous. And in a sense, if you look at the economy, they will have the greatest impact. So to train them well and to educate them well is extremely important. And though, of course, a lot of our time is spent in research, and in fact, most of our time may be spent on research and other activities, over time, I've come to realize that of all the things we do as teachers and researchers, teaching is the most important part of the work. Right? It has, in terms of the impact, but it has the longest lasting impact and the biggest impact. So I had a chance, I was listening to one of the very famous chemical engineers, an interview that he gave maybe 30 years ago, Professor Byron Bird. So I found an old recording, and he was recalling, his, sort of experience as a student and so forth. And what he mentioned was that, he was always talking about his teachers, And one of the things that he mentioned several times, that he's saying, okay, this person, he was a very good teacher because all his material was very well organized and he was able to convey all the ideas very well and so forth. And if you read, he has written, Professor Bird has written, of course, Bird, Stewart and Lightfoot, which, transport phenomena book. So if you read that book, this is really something that all of these are very clearly there in that. So what he thought was good teaching, he put into that book. And that is, how is the course material organized? Does it follow logically? Is the notation very consistent and clear? And then, when you're delivering, is the lecture clear? So these are the sort of very basic things in teaching that we all take care of. Go well prepared for lectures and make sure that students understand what you're saying. Right in the beginning of the course, say very clearly that this is how I'm going to evaluate you and this is how the marking is going to be done. So they know what to do if they want to get an A grade. For students, that becomes quite important. And then there's lots of interaction. I mean, there is no need to be very friendly with students, but you do need to have a nice professional interaction. And all these things are, I would call, the sort of very basic elements that we have to take care of. Today now, there is a lot of research going on how we can use different kinds of pedagogy. And in IIT Bombay also, there's a lot of experimentation going on. So once you take care of all this, then you can try out many new ideas so that you can engage with the students more. And they talk about flipped classrooms where, the lectures students listen to, then they come to class and only have discussions. Then there are many modes of active learning where, students are actually doing things in the class so that they can learn better and so forth. And so all these, I would say, are elements of good teaching. And what I have seen over the years is that if you follow these things, the students will give you good evaluations. So all of us, we take feedback from the students, and this will generally give, good evaluations from the students. But I feel this is not enough, because finally at the core is, what are you teaching? And I think that is something that makes a difference between institutions like HBNI, which are teaching at a certain level, and other institutions in which the graduates are not so well regarded. And the main difference is this: the level and depth at which the courses are being taught, and the rigor and the range of evaluation. And I think these are two very important parts of good teaching. And in the good institutions, a lot of attention is paid to this. And I think this is really very important. And the third thing I feel that is also very, very important, and because it has a very lasting impact, is the fraction of incorrect concepts that are taught in a course should be minimal. And that is not necessarily true in all places. And in fact, one of our senior colleagues, Professor K.S. Gandhi, used to always say that, the main problem that we face is that so many of the students are coming from colleges where they have learned things which are not correct. And then to unlearn them is extremely difficult. And so this is something, of course, we also make mistakes while we are teaching, no doubt. But I mean, we either correct those if they are pointed out, or we try and minimize them. But I think these points are some things that I felt were very important. All of us became teachers. You, of course, joined as researchers here and then went to training school, and then, like Dr. Grover, went back and started teaching and so forth. But we never had any formal training. In fact, rarely do professors have any formal training to teach. And I think it's probably not needed. Because the key thing that I feel you need to be a good teacher is an in-depth knowledge of the subject you are teaching. So that is, it should be absolutely clear in your mind. That I felt is the most important. And as Vice Chancellor just mentioned, that this continuous updating of the knowledge, I think that is really what is required to make sure that at least this part is taken care of. The second thing I believe is that humans are basically learning machines. They naturally want to learn. And the main job of the teacher is to create that interest, to create the environment for learning, as you just mentioned. Because it is not, you delivering material doesn't mean that it automatically just gets taken in by the students. The students have to be interested enough to put in the mental effort to actually learn. And I think this is really a key thing. And what motivates people to actually put in that effort to learn. I think Bertrand Russell used to say that most people would rather die than think. And that's it. You're asking students, you think about things and then try and understand them. And that is not that easy. But one of the things that motivates people very strongly is this possibility of achieving mastery, a challenge that can you master this subject? And that is very appealing somehow to many people. And, they spend hours and hours knowing that, okay, yes, I'm going to become maybe a master of calculus. And so to be able to motivate students, I think that is really the key thing. And another thing that really helps is for people to actually try out things that they have learned, either through problem solving, projects, and so forth. So I think these are some of the things that one can do as to become a good teacher. But what I found, at least in my own personal experience, is that my teaching style slowly became and evolved to try and copy all my teachers who I liked. So I would like to teach just like X, Y, Z and so forth, whether they were in school, whether they were in college, what did they say, how did they say it, and what was the kind of attitude that they had. So those things, we all have had good teachers, and I think emulate your own good teachers. I think that is good enough. Finally, just a few words about teaching and research. And, they are connected in a they're very closely connected, much more than what we think they are. So when we teach, it's a way of learning the subject yourself to a greater depth. Whether you're teaching an undergraduate subject or a postgraduate subject, when you go in there and when you're preparing for that lecture, you start thinking about all those ideas in much greater depth. And, that is a great exercise. And very often when you start thinking about these things, saying that, okay, I'm saying this, but why can't it be slightly different like this and so forth? So teaching, because you are putting so much of your focused effort into sort of bringing all these ideas at the front of your head, that often that sort of thinking is a source for new research ideas. And this particularly happens when you're teaching advanced electives, when you're teaching many new things, and then you start seeing the connections and then coming up with new ideas. And certainly this has often, many of the things that I'm working on in research have often come from ideas that I've got while teaching. And what has already been mentioned is this research also helps to continuously update knowledge and teaching material. So when you're doing research in a particular area, and let's say you're teaching an elective in that area or something, so what is the new thing in there, and then you can bring it into the course. But there's also mindset that, when you're doing research, you're thinking in a particular way. When you're just trying to read and deliver the material, you have a certain mindset. But when you have a research mindset, you're constantly questioning everything that, okay, why is this like this? Why can't it be this way? And so forth. And that research mindset often helps identify gaps in your presentation to the students. And certainly that could help in the way you teach. So basically, teaching and research are very closely connected in this way. And as I said before, I feel teaching is the most important activity. We may not spend the most time on it, but it has the biggest impact. But research is also very important because in most research universities, research is what is used to evaluate academic excellence. But, as teachers, we have to make sure we get into the right balance so that we do both of these in the right level, and both will feed into each other. Let me now just switch gears a little bit and say some things that are of a more general nature. So there's been a lot of talk about what is going to be the future of higher education. And there have been many studies on this. And I want to tell you about two of them. And a lot of this debate is driven by, one is that so many new technologies are coming out. And the second is that the cost of education is extremely high. Cost of good education is extremely high. So this is one report that came out in 2013. And the title of the report you can see is quite sort of, alarming. And it says an avalanche is coming. And then one of the paragraphs is that historical change is like an avalanche. The starting point is a snow-covered mountainside that looks solid. All the changes take place under the surface and are rather invisible. But something is coming. What is impossible to say is when. So they felt that, there's going to be a big change in the whole education and the way it's delivered and so forth. We are seeing changes, but so far not such drastic changes. And, what are some of the challenges that are driving this, what they feel this big change that is going to happen in education? What are some of them? So one is that the economy and technology are changing fast. And so, these things have to be sort of incorporated into the education. The economy is concentrating wealth. And, because of all automation and so forth, is generating unemployment. And this process is aided by university education in the sense that those with university qualifications get jobs and the others find it extremely difficult. And, you're seeing this where so many people are now working in sort of jobs that are not this regular kind of monthly paying jobs, but more on contract or delivery or whatever. Another thing is that the cost of education is increasing faster than inflation. So if you look at it, it's actually increasing much faster than inflation. And the value of a degree is decreasing because there's so many more degrees. So, that the advantage that you get is decreasing. But at the same time, if you don't have a degree, then you are at a bigger disadvantage. So the importance is increasing. Another thing that has happened is that you can essentially get content for free. So you can go to the web and learn about almost anything. And, today you can even just go to the YouTube and listen to lectures, excellent lectures on almost any topic. And of course, there's a lot of competition. So there are high cost universities in the West, but then in developing countries, you have very good education possible. And then there are new technologies like this massively open online courses in which at a low cost people can sort of get education. So they feel all of these pressures are acting on the university system as it exists. And so things are going to change over time. And, what are some of the things to think about is how can universities and new providers ensure education for employability? And how can the link between cost and quality be broken? How does the entire learning ecosystem need to change to support alternative providers in the future of work? So, these are some of the questions. The answers are not very clear, but certainly, there are various things that are happening. And, we see our own students doing various things. Like, it's not uncommon for our students, for example, to take courses while they are studying their MTech. They may be taking courses in data science or something like this, just to, in a sense, enhance their possibility of getting a particular job. And even if you now get a job, even in a core chemical company, very often data science is an area where, which may become very important for them and so forth. So, and some of the trends that are already taking place are that, that students have the option of scheduling in terms of time and place. There's a possibility of personalized learning, so people can do different kinds of emphasis in their degree. So there is a lot more student ownership of what they are studying. There's a lot more of, project-based kind of education, field-based education. A lot of things related to on data, the new ways of assessing, and then of course now mentoring is becoming more important because all the information is available. So then students are really looking for guidance on, what should we do next, what should we study, how should we study, and so forth. The second report I just wanted to tell you about is a little bit more specific towards engineering. And so they did a report just to find out, what are some of the major trends in engineering education. And again, this whole idea that all the top engineering education is concentrated in the Western world, that is certainly changing. And it's shifting to various places in Asia, South America, and so forth. There's also a lot of move towards socially relevant and outward-facing engineering curricula, which emphasize student choice, multidisciplinary learning, and societal impact, coupled with direct student experiences. So, students are actually going to places and trying to solve problems using their engineering skills and learning at the same time. And so it's not just sitting in the class and solving problems, engineering problems, but actually learning part of it and then going to the field and trying to, or going either to the industry or to the field and then trying to apply their knowledge right away. And there are many of these colleges which are doing this. And there's a new generation of leaders in engineering education who are doing things very, very differently. And the students are getting a very different kind of education. In our own place, Professor Sanjay Mahajani is doing some really interesting things. And one of the things he does is something called Course on Wheels, in which in the winter vacation, he takes 30 students on a bus, and then they go from industry to industry, from Mumbai to, Hazira, to the Reliance plant. And on the way, they stop at every industry, and they do a thorough, review of the particular process that they are there. The plant people give lectures, the professors give lectures, their homework assignments, tests, and so forth, to get a real insight into, how the chemical industry works and so forth. Extremely popular course. And, so students have to be said, okay, we don't have any more place. So, those kinds of things are being tried out and they are making a difference to the students. So, these are some of the other things, like, as I mentioned, work-based learning and so forth. Of course, there are many challenges because many of these new ideas that are being tried out are non-conventional. And so there's not that much faculty buy-in because, there's a monodisciplinary culture in most places. So people are in particular disciplines. And then faculty appointment and promotion don't, give faculty enough time to try out some very, very new things. So there are many challenges to going in this direction as well. Let me just speak a little bit about technology. Several years ago, in one of our alumni meetings, we had invited Andrew Ng, who was the founder of Coursera. This is one of the first companies to start delivering MOOCs. And of course, he's a professor at Stanford also. Now he's back at Stanford, I think. And so, it was quite interesting because I think that was the time when MOOCs were just about, reaching their peak. And, he was the owner of a company that was delivering this kind of education. And, what he said in his talk was that, at various stages in the development of new technologies, people often felt that, okay, now universities are not required. So, when the telegram came, a lot of people said, okay, now why do students have to go to universities? They can just get the lecture notes by telegram and study them and then give an exam later. When radio came, then they said, oh, lectures can easily be delivered over the radio, and television, the same thing. Then there was this big movement when PCs came, where there's this computer-based education where, there were these CDs that you could put in and then go through courses and so forth. And then, of course, once internet came, then there was the advent of MOOCs where entire courses could be taken with tests and lectures and all sorts of things. But somehow the universities have continued to flourish, and institutions have continued to flourish. So what this says is that technology is important, and we keep trying to use it. But that there is it would be very difficult to sort of replace the teacher. Because the role of the teacher is, as we have already said, is not just to deliver material. That material is available everywhere. So there is something more that a teacher does. And so even though there's so much technology and it can be used in many ways and many of the people are using it, but the teacher still remains at the center. And we got some feel for, the role of technology during the lockdown, because suddenly, all the students were sent home and they said, okay, now you figure out how you want to teach. And there were some of the faculty members who were already using many of these online techniques. So they gave us lectures to try and get us prepared to be able to teach online. And of course, very quickly, we had to figure out how to do things. And though I was initially very worried about this, that how will I do this? How will I teach? Because I'm teaching big class of, 80, 90 students, and, what is going to happen? But then, they have these tablets and everything was available. And very quickly, we got set up to give live lectures using these tablets. It conveys everything very nicely. All the lectures were recorded and uploaded for the students to listen to. All the presentations were uploaded. All the handwritten notes were uploaded. Everything, all the material was there. Quizzes and exams were a problem because there's, no way of really doing good invigilation. But one of the things that I did was I said, okay, now all books are open book. I mean, all tests are open book, open notes. You consult anything you want. But, so that you don't consult with each other, I'm going to change the question papers in a random way. And now on, many of these learning tools, they will allow you to do that, so that, the questions will come at random. You can, from let's say bank of questions, a random one will be taken and given to, so each student will have some different question. In a particular question, you can actually change the values at random and so forth. So all these tricks. So it sort of went through. And I would say by and large, I was happy with how smoothly everything went. And, the students were there, they were attending. But, both from the side of the students as well as from my side, the engagement was low. I mean, that connection with the students just didn't happen. And I never really got to know the students, like, in a class that you get to know. And so there was a difference. And then, so, after this lockdown ended and the students all came back, so I asked the students, I can come to the class and lecture. So do you prefer me to just write on the tablet and then, it'll get projected on the screens and then we'll record it and then upload it? Or should I write on the board with chalk? Almost 100% of the people said chalk, that they were not interested in. So there is something about this process of, conveying information by writing on a blackboard. That is, and I think it's to do with the speed. Is the speed with which you write on a board is limited, and that gives enough time to sort of absorb and understand. So chalk and talk was what is the student's preference. And here I just end with we are not very different from, so this is something in the 12th century, about 800 years ago, they were like this. And we are still like this. We still have, some student will be sleeping in the class. Of course, now when our classes are beautiful like this, and, we can project all sorts of things and all this. But finally, it's about like looking into the student's eyes and, making that connection and, the student feeling free enough to ask questions and point out mistakes and all those things. And I think the technology is there, but the teaching process is somewhat not entirely tied into that. Going too long? Now, so this is the last thing I want to talk about, and this is something I've been feeling more and more, is that now computations have become very important. I mean, Professor J.B. Joshi is here. He would have been giving this talk maybe 10 years back because he has been using computations for maybe 30 years or back, I don't know. But things have changed, literally computational in teaching and research are now, it's just, they are inevitable almost. So I remember as a student, I was attending a seminar by one of the famous professors from Minnesota. University of Minnesota had just got the new Cray supercomputer over there. And so this Professor Scriven, he came and he said that, look, now you stop all this, saying that, we want to solve for concentration distribution in a sphere or, making all these approximations. Stop all this. Now the supercomputers are here. You must solve everything in full detail. But the reality then was that supercomputers were very expensive and most researchers even didn't have access to it. And of course, undergraduates had absolutely no access. Software had to be written from scratch. So if you had to solve any problem, it was almost like a PhD level research just to develop the software and then you solve the problem. And so though there was a lot of impact of computers on research, and in my own research, I used a lot of computations, but there was very little impact in education. That we almost use no computers in education, even at the graduate level. But things have really changed in the last 30, 40 years. The kind of computers that we are getting now at a very reasonable cost are extremely powerful. You're getting multi-core CPUs on laptops. And, if you want bigger problems, you can just go and purchase time on these cloud servers, and those are not very expensive. So this is one thing, the hardware cost has dropped like anything. And the second is that very powerful free open source software is now available. So you can actually solve very significant problems, and these resources are available. So one of the areas I've been working on for a long time is on this flow of powders and particles and so forth, which appears in many situations. And this is just one example of the kind of work, we did lots of experimental work, very detailed experimental work. And here is an example where we used image analysis to find out the velocity of individual particles. So each streak is formed by one particle moving. And through image analysis, we could get exactly the length of the streak, and then we could get the speed and so forth. And then by doing this for large numbers of particles, so in this type of system, we could, get very accurate velocity profiles and so forth. So we could do all these kinds of measurements and so forth. But over time, what we came to realize that there are problems. One is you can make measurements only at sidewalls because, this is the opaque system, you don't know what's going on inside. To measure stresses is almost impossible. And then there are always wall effects. So people will always ask you, like, what is the effect of the wall friction and so forth, which is difficult to kind of. So then over time, we started using computations, using this thing called the discrete element method, in which you follow how every particle moves using Newton's equations. And very much like molecular dynamics. And then you take into account the forces between particles, which are friction and compression and so forth. And of course, this method was developed first in 1974, but it was the computers were so bad then that they could only do 6 particles in their paper. So they had a result for 6 particles. So we wrote in-house code, and several PhD students graduated using, these codes to generate new results and so forth. And, slowly we were solving these things. But, in the last few years, we've come to stop using our in-house codes, and we started using this new, not new, but we started using this very powerful open source software called LAMPS, which stands for Large Scale Atomic Molecular Massively Parallel Simulator. So it can it basically does molecular dynamics. And you can see that here there are 2 things that they're highlighted. One is download and the other is manual. The download is just like, it's free. You just take it and it'll land on your computer. It starts working within 2 minutes. And this manual, I have not seen a better manual. It's so beautifully written. It is so clear. So you can use it. And today now, I'm not asking my students to develop in-house code to do the simulation, because this is here. It's a parallel code. You can run it on an HPC, whatever you want. And you concentrate on the actual problem you're solving and don't bother spending time on doing the code development. And I'll just give, this is one example of one student's PhD work, where now we're looking at 130,000 particles in a hopper. So this is a very commercial sort of system that, you have a hopper, converging hopper, and particles are flowing out through the small opening at the bottom. But, we are not solving a traditional problem. There is a very famous theory which is developed for this system, in which the gravity is assumed to act in the radial direction, not downward, but it's acting in the radial direction in this conical system. And the walls are assumed to be frictionless. Now, to build an experiment like that is impossible. But for computations, we can easily do it and then make a direct comparison to the theory to validate the assumptions and so forth. So this is just one very powerful thing. Another student is looking at polymer chains. Now, PVDF is a material that is used for piezoelectric. And, the chain conformation makes a big difference. This has got CH2, CF2, that's the repeat unit. And if you look at, the red atoms, they are fluorine, the blue are hydrogen. And, when you don't stretch it, then they are arranged on both sides of the chain. And if you stretch it, then all the fluorine go on one side, all the hydrogen go on the other side. And because of this, there is a dipole, and then that creates the piezoelectric property. So, by doing molecular simulations, using accurate force fields and so forth, you can actually see that as you stretch the chain, how it transforms from this alpha to beta phase. So this is not piezoelectric, this is piezoelectric. And then, you can do various thermodynamic calculations like free energy change and so forth to be able to understand what is going on. Again, done using lamps. So my message is that, one very detailed analysis possible with measurements that cannot be done using experiments. And you can just vary parameters independently. If I want to change the friction, I can change it to whatever value I want and so forth. And you can get a lot of new insights, though of course, the caveat is that we must do validation, and then so experiments have to be done in parallel to make sure that the results are sensible. But so this, of course, this is a very natural thing. People have been using computations in research, but computations in education have not been that used to that extent. And I started once I got introduced to lamps. Then I teach this elective course on granular mechanics. It's a postgraduate elective which is open to undergraduate students. And in this, I give an introduction to lamps. So when I first started teaching this elective, I used to teach the students the elements of programming. That is, I would explain to them how I developed my code. But then later on, I said, okay, now let me just teach them lamps. So I started giving them an introduction to lamps. But I must say that when I started, I did not know lamps. I had never used lamps before. When I decided I'm going to teach lamps, because for me that has always been a strategy that if I want to learn something well, I should decide to teach it. Because you can't go out there and not know when you go up in front of the class. You can't sort of be scratching your head and all. So, and this was really effective. Very quickly I learned lamps. And the students in this course were supposed to do a homework assignment using lamps, and then they did a project based on lamps. And then now, I mean, all my PhD students who work in granular materials, they know lamps. All the MTech students know lamps. Another course that I teach regularly is this process fluid mechanics to second year undergraduate students. Now, I was teaching this course after a gap of maybe 10, 12 years. And in those 12 years, what are another things that became very clear to me that fluid mechanics is no longer what it used to be. Today, you cannot do fluid mechanics without computational fluid mechanics. I mean, nobody is really interested in analytical solutions to the governing equations. So I felt that it was important, even in the first course, to give at least some exposure to computational fluid dynamics. So I decided to teach the students OpenFOAM. Now, IIT Bombay has a subscription to ANSYS Fluent, and that's a much easier thing than OpenFOAM. And I could have used that. But I intentionally decided that I would teach the students OpenFOAM because, when they leave IIT, it's not guaranteed that if they go and work for a company, that company will have a subscription to ANSYS. So for companies to subscribe to ANSYS, they have to pay a huge amount. But this is a tool that they could use even on their laptop. So again, in this course also, I taught them this. I did not know OpenFOAM. I never used it before I decided to teach it. And then, I think I'm quite good. I've taught this course 3 times. So by now, I know OpenFOAM as well as the students know it. And again, I gave the students one homework problem and then a group project, and And so, this is really very powerful. It's multi-physics, not only flow, but also heat transfer, solid mechanics, everything can be done in this. And it's completely open source. You can download the thing, look inside every program and change whatever you want. And it's available on all systems. And, so this is a little advertisement for OpenFOAM. And this is, just one example of a problem that students did in their course project, which is flow past cylinders, flow past cylinders. So, this is a sort of periodic system, and there are these cylinders on a triangular grid, and then they have to calculate pressure drop and flow, and they can do it. I mean, and this is not something that they can do analytically, but it really gives them a great hands-on sort of experience. So this is what I'd like to sort of finally end with, that this open source software is extremely simple to download, install, and use. And it can solve reasonable scale problems even on a laptop. So the students are just installing these on their laptops and solving these problems. And it gives students some hands-on experience. And of course, once they have access to this tool, even later when they go and work in industry or wherever, they always have this. They can always use it and so forth and solve problems. So with that, I'd like to conclude. Thank you for listening for so long. So let me again say on Teachers' Day that teaching is the most important thing that we do. And good teaching, in addition to everything else, requires depth and rigorous evaluation. I mean, those two things we must keep in mind. Teaching and research are very closely connected, and especially for academics, one feeds on the other. And one point that I didn't mention is I've always found that whoever are the best teachers, they end up getting the maximum number of PhD students. So you just have to look at Sanjay Mahajani, Juvekar. They are the two best teachers in our department, and the students used to simply flock to them. So there's a really very strong connection. Technology will never replace teachers, but we can use it to make things a little bit more clear. And then these computations are becoming very, very useful. And I think we all have to sort of put in some effort to learn and bring it into our teaching and research. So thank you very much. And I wish you all the best.
Thank you very much, sir. So if you have any question, those who are online, especially on YouTube, they can put the question on chat mode. Other people, those who are on WebEx, they can raise their hand for the question, or here in person, those who are attending, if they have any query or any question, they can ask.
Call it question or comment. Nicely said that technology cannot replace a teacher, and there you list is Telegram starting at the top and ending with MOOC and internet. Long back, I remember reading some article or a paper somewhere, how when printing press came and books started publishing, and availability of books became much easier than what it was earlier. And in that article, comment was it changed the role of a teacher to some extent. But in your what you have said, that yes, all these technologies have come, but the role of teacher still continues.
It does change, because now today in my class, I know that the students are sitting with their cell phones.
Yes.
And they're ready to check anything I say. That is a difference, where at one time I had the knowledge and the students did not have it. When the textbooks came, they could refer to the textbook. But if I was giving some advanced knowledge, most likely they didn't know it. They couldn't easily check. But
yes.
Now that's no longer.
Now they can check that. So what that said was that it really sort of kind of diminished to some extent the role of teachers. The books came into being. I mean, and after that article, I started. I read that article, must be some 7 or 8 years back, and started wondering about what we call in India as Guru Shishya relationship. books might have changed that from what it was 2000 years back to what it is now. So this is only a kind of
No, I agree. So at one time, the teacher was not only the way of knowledge, but also the storehouse of knowledge.
storehouse of knowledge. Yes.
There was no other source. I mean, you had to go to them if you really wanted to learn something. There's another aspect to it. One is the actual information,
Yes.
and the second is the apprenticeship. That you learn some things by doing with. So, even in research, though we say research is sort of different from that, but research is also when you're guiding a student, that is training, training through apprenticeship. And what you see is students who go and work in let's say, a lab of some of the top scientists do extremely well later because they learn things, they learn a certain culture, they learn, which is really difficult to convey just through books.
True. Yeah, that's right. So role of teacher will remain, though it will keep evolving. Yes.
Okay, Professor Sulekha Mukhopadhyay has some query. That is on, just check that.
25 years back, I was in your class in Advanced Transport Phenomena in IIT Bombay. What amazed me always, and today I want to pose you that question, how you could carry the whole class, maybe about 50 plus students with you when you were teaching very coolly, calmly, with lot of theoretical equation involved. And there is a mass difference in standard of students. And how you could pull all of them together. Why some people, I was 30 plus that time, I had my child and I joined the class. We never felt that you are going too ahead, too fast, and I'm not able to catch the class. How you could manage it very coolly. And whoever will ask question, you will very calmly answer to that question and explain the thing. In spite of that, how could you finish the syllabus at time? And that is a
Because it's that moment, that when you are actually conveying that initial start, when all the basics are being conveyed, if a lot of time to teach that, then I feel like, once actually everything is very easy. Saying something and you're not understanding it. Then it becomes very easy for the students to understand. As I said, I always modeled myself on no need to rush. If you are not understanding what you're saying, then
So we have seen teachers who are very knowledgeable, but this conveying thing doesn't come very well with everybody. But it came somehow very nicely with you. Thank you, sir.
First of all, compliments for excellent and lucid lecture. And on the day of Teachers' Day, it was most appropriate that you gave that presentation. I liked one part very much, that is balance between teaching and research. It is very, very important. The textbooks are, of course, very useful. They have solved one problem, but I may comment, teachers, the textbooks have helped teachers also, in addition to this. Yeah. Now, one more component in addition to teaching and research is the reality. That is, having solved some problems, were they real problems? So implementation of those solutions in the society, maybe it is industry or society itself, and while implementing those solutions, we get many more problems, which are. So you really mentioned about implementation in terms of Sanjay Mahalesh's efforts. But I think it should be spread across the teachers that they also try to become advisors, whatever in any form, but implement it, and then whatever they learn there through research, teach in the class, what students ask, implement in the industry. So in one more balance we can.
Yeah, so I think that teaching, research, and then the foundation themselves have to strive for, so then they. I think that is a.
When it is implemented, even industry people and industrial problems can make the teacher humble, and that will improve the quality of teaching. So this is one more. Another point I wanted to say, the open source softwares are very, very useful. They have simplified. But I think students, they should not take away that it is a black box. So they should be trained up to certain extent, then only they should be permitted to use the either ANSYS or whatever.
Learn the.
Another is while teaching fluid mechanics and solving the problems like Bird-Stuart Lightfoot, all of us know that that is not sufficient for teaching what is reality. So from there, a course on turbulence, which is most difficult, before we go to software, and we know the limitations of software, and unless turbulence is understood, these softwares may not be understood. So a course on 30-40 lectures on turbulence, I think it may be a good idea prior to the.
What I do is tomograph length scales and then so that they can see all the equations. I explain to them, what the discretization of the governing equation, that
At least they can solve laminar flow through pipe, turbulent flow through pipe, heat transfer accompanied. So 4 or 5 basic problems, if they solve, then they can go to open form and it's a good idea. Natural convection.
Questions are online, but at least to see that we are able to attend to the online members.
Yeah, we have already asked them and. Oh, okay.
No question. You can stop the online discussion.
Yeah. Any online question? No, there is no. I have already asked. Yeah. Okay. Thank you, sir, for giving us such a wonderful and nice talk. Now I request Professor Dureja to give proposed vote of thanks.
Good afternoon, everyone. It is my great privilege to propose vote of thanks on this very special occasion of Teachers' Day. So, I would like to start with this doha. Guru Govind dou khade kako lagu paए, बलिहारी गुरु आपके गोविंद दियो बताए. So मैं सभी गुरुजनों का अपना नमन करना चाहता हूं, जिनकी वजह से मैं आज यहाँ खड़ा हूं. मेरे 2 गुरुजन प्रोफेसर ग्रोवर और प्रोफेसर दत्ता यहाँ उपलब्ध हैं. So first of all, let me thank Professor Khakhar for taking time out from his busy schedule and illustrating the directions for imparting knowledge and transfer of knowledge. It was indeed our pleasure to have you here, sir. We have made note of points illustrated by you on technical higher education, and we'll try to imbibe this in the framework of HBNI. Thank you so much, sir. On behalf of HBNI, we want to thank Professor Grover, Founder, Director, and Vice Chancellor HBNI, for always encouraging us to come out with new ideas and support us to execute this. Thank you so much, sir. I am personally thankful to Vice Chancellor, sir, and Dean, sir, for creating enough opportunities for us to organize such events. Thank you so much, sirs. We are thankful to Professor J.B. Joshi, Emeritus Professor HBNI, and Professor B.K. Datta, Institute Chair Professor, for guiding us. We are thankful to we at Central Office are grateful to directors and faculty members of HBNI placed at various CIs OCC across the country who enthusiastically participate in all the programs and give their full support. On the occasion of Teachers' Day, I want to thank one and all. We are thankful to all the dignitaries in this hall and online for accepting our invitation and sparing your valuable time. This event would not have been a success without the active support of all the staff members of HBNI who directly or indirectly help us in arranging these functions. The technical support provided by IT team, HBNI is always excellent, and I want to thank each one of them and making these events great success. Thanks one and all. Jai Hind.
Now I request our Vice Chancellor, Professor Basudev Rao, to hand over a memento as a... Sir, just one small thing. Yeah, one small thing is there. I request our Vice Chancellor to hand over a small memento as a token of appreciation. Yeah, so now the program is closed. You can close online. Yeah.